Ladies and gentlemen, please note the following down. If I have not told you already, try and understand the assumptions or the properties of regression. Try to understand the assumption or property and all the properties of regression. One of them has to do with this zero mean value of the error term. That assumption says that the mean value of the error term must be zero. The mean value of the error term should be zero. And you want to note that down and understand what that means fully. Another assumption is homoscedasticity. Another assumption is autocorrelation. They are all about the errors. Everything I've said are about the errors. Another assumption is zero independence between the error and then the regressor. Zero independence between the errors and the independent variables. You have to know what that means. You also want to know the next assumption, which is linearity. And the other assumption, which is no perfect multicollinearity. Did I define multicollinearity with you guys? I think I did, right? Did I explain multicollinearity? Noella, Aqua.
Yes, please.
Which one is a yes, please?
You defined it the last time we met.
Perfect. Okay. Now, so try and get to know the assumptions of regression. Please note that. Okay. Let me quickly talk about dummy variable regression. What is a dummy? A dummy is something that is constant. A dummy is something that is static. The word static also comes from the word statute. Statute. And that is why the word statute is something that is law, unchanging. So a dummy variable is a categorical variable that is not changing. At least within a year, it is fixed over time. In this study, we've looked at several dummy variables. Maybe you haven't fully taken notes, but there are a number of dummy variables. One of them was location, the other was occupation, and the other was religion. The number of levels refer to the content of the dummy. So under location, we had how many levels? Who can tell me? Under location, we had how many levels? In this Brukutu venture data set. Under location, how many levels do we have? This is a question to all of you, by the way. I've already started a recording, so take notes that all of these are useful. All that you say. Latif.
No, one.
Under location, how many levels do we have?
One.
What are they? What is that?
Urban and rural.
Okay, but that is not one thing you said.
It's n-1, so.
No, it's not n-1. The number of levels is equal to the number of dummies plus 1. the number of levels equals the number of dummies plus 1. And so if there's a dummy, which is location, then the number of levels are the content of that dummy. And in this case, the contents are rural and urban, which is 2 levels. Remember that the number of levels are 1 more than the number of dummies. And the number of dummies are 1 more than the levels. So take it. Now, under occupation, how many levels are there? Who can tell us? Under occupation, how many were the levels? Under occupation. Latif.
3.
There were 3. And how many were the dummies?
2.
2, exactly. So the number of dummies are always 1 less than the levels. Okay. So Latif, you got 4 marks already on this. Now, under religion, how many levels are there? Under religion, how many levels are there? Noella?
3 levels.
3. And how many dummies are there? Noella?
2.
What were your 2 dummies?
3 minus 1 makes it the 2.
Okay. Can you mention the 3 levels that you said they are?
Buddhist, Muslim, and Christian.
Very good. So it's important to know about the dummy variables. Okay, so let's get into the nitty-gritties of what we've been doing, and then we can understand fully. Okay. You should be able to know the levels in any dummy variable situation. Let's take our data set, Brukutu. Please, by now, you want to open your Brukutu data set in Excel. And you also want to open your RStudio. Your RStudio. We're about to run some analysis and explain them. Under the exam condition, I will do the same thing and I'll ask you 13 questions. We're about to answer those 13 questions. Please note that the topic on regression correlation is compulsory. So because of that, you want to really pay attention. You are writing a thesis paper, a long essay paper. And this long essay paper you are writing, it is entitled Determinants of Demand in the Alcoholic Beverage Industry in Ghana. You've already confirmed that there are factors that can affect the quantity demanded of a product, in this case, of alcohol, gin bitters. You have already established that. What you want to prove is that previous studies have not looked at the impact of location and occupation. So you want to incorporate occupation and location in addition to the price, the complement price, and several things. Now, when you look at religion, you were able to confirm that religion has been looked at before, but the only thing is that they've never looked at Buddhism. They always look at Christianity and Muslim, not Buddhist. And so you want to incorporate Buddhist with the data set, apart from having the Christian and the Muslim religion. So you gather data, and in the data, you generated descriptive statistics. We looked at this last time. You created contingency table and graphs. We looked at that last time. You even did univariate analysis. What do I mean by that? What I mean is that you were able to check the distribution of the data. You were able to determine that some of them were normally distributed, some of them were not normally distributed. You check that, you use the kernel density to confirm that. So you've done several things. Today you want to proceed and look at regression. And you want to do that by first dealing with single regression or simple regression. So if you are ready, let's get the ball rolling. Okay. Let me see by hands those of you who have opened their RStudio, and in their RStudio you have the command running. You have this command written in your studio, and the command is gen equal to read.delim. So let me see by hands those of you who have your RStudio with the command I have highlighted here. Raise your hand. If you have the RStudio with a command I have highlighted here, raise your hand for me. I mean, if you have typed it. If you have typed it already before coming. Raise your hand for me. I have 7 people so far. Keep your hand raised though. Some of you are not sure whether to raise your hand or not. So raise your hand if you have your data loaded and you have this command shown. Okay, so I have 9 people. 9, 10. Some of you are not sure. Please, everybody, use your full name in the chat, because when I'm giving marks, I deal with full name or ID or ID. Use your full name. Ken. Use your full name. Okay. So I want you to go to your Excel, and I want you to copy the data set in your Excel. When I say go to your Excel and I say copy the data set in your Excel, this is what I mean. I mean, go to your Excel just like I have gone to my Excel. Copy the data set. How do you copy it? Well, click anywhere inside, do Control-A to copy, Control-C, Control-A to highlight the data, Control-C to copy. Control-A to highlight, Control-C to copy. David Jakite, remember to change your name directly on your computer, not to me. Don't send it to me. Okay. So we take this data, go to R. And when you get to the RStudio, you want to now look for gen equal to read.delim. Run that. Click on it and then click run at the top, or click on it and type and run. Control key down and then enter. Do Control key down and enter. Keep your hand up if you have done that. Keep your hand up if you have done that. Now go to attach gen, the command. This command attach gen, it will put the memory of the data into, it will put the data set you have typed into the memory. Once you are done with that, keep your hand up. In order to see and be sure that your data is loaded, just highlight only the GIN, highlight it and run it. When you run it, you see the data showing down there in the console. That is the data. What is this data about? It shows a relationship between the quantity demanded, which is Q, being influenced by several factors. Some of the factors are numerical, some are categorical. Who can tell me which factors are categorical? Lower your hands, everybody. Who can tell me which factors are categorical? Who can tell me which factors are categorical? I think my screen is loading up. It will come back again. If the screen goes off, allow it some 1 minute to return. Let me go to Richard Nyame. Richard Nyame, your hand was up, right? Richard, was your hand up? Okay, so you have quantity demanded being affected by price, complement price, the income of the shop. Note this down. The location, the income of the people, the location of the shop, the occupation of the people, and the religion of the people. So Elizabeth, tell me all the numerical variables and all the categorical variables. Elizabeth Frimpong.
So the numerical variables are the quality, the quantity, the price, the C and then M, and
No,
then the
you should
categorical.
know their names now because we are going to make sense of them later. What is their full names? You know, I repeated them some few minutes ago.
Yeah, but I find it.
It's because you are not paying attention. That's what it's doing.
Oh, my network was messing up.
Who can help it? And the rest of you who are not paying attention, you will show up today. Andor.
So the categorical are the location, occupation, and religion, and the numerical is the price, the complementary price, and the income.
Okay, good. So these are the categorical and the numerical variables. You should know them very well. Okay, you have attached the data. So run the command called attach gen. Okay, I'm sure you've already attached. If you haven't attached, attach it. Then let's go to the next command, which is the plot. Plot kill. That will generate the sample regression for you. So please do the plot. Kill regressed on price. The quantity demanded of gym bitters is regressed on price. So do that, run it. When you have run it, you should get a scatter plot, just like I have a scatter plot here. Then to have the, by the way, when you look at the scatter plot right now, just between price and quantity, does it look like the relationship between them is negative or positive? You can tell me. The relationship between them, is it positive or is it negative? Augustine.
It's negative.
How do you know? Fred, Eric Bediakon.
Yeah, it's positive.
How do you know?
How do you know?
The higher the price, the higher the quantity. The higher the quantity, the higher the price.
That is not correct.
That is not correct.
Who can tell me the correct answer? What is the relationship between price and quantity demanded here? Elizabeth Frempo.
Please, it's positive.
Why? Your friend just said the same thing, and I said it's wrong, and you have repeated the same thing. You have to be here. I know you are not here. Most of you, my permutations tell me that about 80% of you are not yet here. So try and be here. Kalechi?
And please, is negative.
Some of you say
Because
it's
the
positive. Some of you are saying it's negative. So why?
Yeah, it's negative because it's sloping downwards from the left to the right, which is showing a perfect demand curve.
Not a perfect demand curve, but it's showing some kind of demand curve. So let's put the line on it. That's okay. It's negative. It's negative. The answer is better than those who are saying it's positive. But to see whether it's negative or positive, run the next command, which is called the gene sample. That will put the line. Okay. So run the command, which is called gene sample. You see the result of your gene sample down there in the console. Then go back and run the plot. After you have done the gene sample, go back and run the plot. And this time the plot should have a line through it. And that line is showing the negative relationship purely. So who can tell me what is the difference between the dots and that of the line? What is the difference between the dots, the blue dots here, and then the line? These are examinable. In the context of what we have discovered and in the context of your data, what is the difference between the dots and the line? Latif.
Look, the dot, the relationship is showing how far away the dots are from the mean.
Okay. So what is the difference between the dots and then the line? That's my question. What's the difference? Abapa Ando.
So the line is the slope, and then the dots is the individual demand and the price.
Okay. So you're saying the line is the slope. What do you mean by the slope here? The slope of what? And again, the slope is too technical for somebody to understand. What do you mean by the slope?
So the slope like can be equated to like the mean. Or the relationship, I don't know. The relationship, that's the slope of the demand curve. I don't know.
So ladies and gentlemen, the dots, the blue dots refer to the actual values of the connection between the quantity demanded and the price. So it shows the meeting point between each quantity demanded and each price. So go to your data. So when you look at your data, what is the third quantity demanded? What is the value of the third quantity demanded? And what is the value of that third price? You can tell me. What is the value of the third quantity demanded and then the third price? Eric Bediakon.
The third quantity demanded is 200, and then the third price is 13.
No. Who can tell us the third quantity demanded and then the third price? Wilfred.
Doc, the third quantity demanded is 160, and then the price is 15.
Very good. So the third quantity demanded and the third price are 160 and then 15. Where they meet is the actual quantity and price. Actual quantity and price. So that is what the blue dot is signifying. Okay, pay attention. I've already seen it. Okay, that if you don't pay attention, you might find a little bit lost. So that is it. What you are seeing is that it's not showing all of them, but it's dead. Most of them are there. The scatter plot is showing those combinations. So on the axis, at the horizontal axis, you have the prices there, and you can see that the values are between 12 and 18 because that is where the prices are hanging in between. Then on the vertical axis, you have the quantity. Okay. Now, the red line refers to the fitted line. It is not the actual quantities, but it is the predicted quantity demanded. Now watch something here. This is a simple regression. And when you're writing a specification of a simple regression, this is what it looks like. Q is equal to beta naught plus beta 1 price plus the error term. We looked at this the last time. Okay. So this is a simple regression because the independent variable is only one, and that is price. Price is the only independent variable. And then quantity is the only dependent variable. Now, once you estimate the model, pay attention, pay attention. Once you estimate the model, what will go away from this and what will change? Okay, the last time we looked at estimated regression equation and a specified regression model. Once you estimate this model, what will go away? Latif.
The error term.
Good. There is an assumption in regression, and I've told you to go and learn all of the assumptions. There is an assumption in regression which says that the expected value of the error term must be 0. I repeat, the expected value of the error term must be 0. That means the mean of the errors must add up to 0. So we expect this error term, which is a u here, to be 0. But what else will change? You can tell me. Now that the u is gone, what else will change? What else will change? What will be replaced? That's what I mean. Once the u is gone. Latif.
So the betas will be replaced.
Perfect. So the betas will be replaced. And when you go to your model, you will know whether or not the betas have been replaced. So I want you to look at your model, the result of the model on the left. You'll come to that though, but look here. You see that there's a column known as estimate. Estimate. Which one represents the beta naught? Which of these estimates represent the beta naught, which has to be replaced? So you will still have the quantity equal to the beta naught plus something p. Which one here is a beta naught? Which has been replaced? Emmanuel.
Is the 390.376.
2 decimals, what will it be?
0.38.
Good. So the beta naught is going to be 390.38. Follow me, don't sleep. And which other one will also be replaced? What else will be replaced? Latif.
The price.
Not exactly. The price will not be replaced.
The beta one.
The beta one. Are you doing lottery so that in case one fall into it, then you are right? Or what?
No.
What is no? How do I believe that this wasn't a guess?
Well, because the P has a value there, I was thinking we're going to replace it in the actual.
Okay, so this beta one is going to be replaced with what? Latif, you said it. The beta one is going to be replaced with what?
The beta one, I'm not sure. I'm not sure of what to be replaced.
All right, okay. That is also why I also knew that you are not, you were guessing. Okay. Now, what will be replaced? The beta one will be replaced with what number? Emmanuel Hansen.
Well, please, it will be replaced with negative 14.26.
Very good. Excellent. So the beta one will have to be replaced with negative 14.26. And that is down there in the price. Because in this situation, the beta one represents the estimate. Write it down, write it down. The beta one represents the estimate or the coefficient of price. So you write that and attach the letter P to it. This top information that you have is what is known as the specified regression model. And what you have down here is the estimated regression equation. So the estimated equation is this. That's what you see down here. And what is happening is that you have estimated the equation. So if we now replace the value of P, if we replace the value of P with a number, then we can always find the value of Q. If we replace the value of P with a number, given these numerical values, we can get the value of Q. And that value of Q you can get is what is known as the predicted Q. The predicted Q. Sometimes it's also called the fitted Q. Okay. The predicted Q. This predicted Q is called cap. It's given a cap. It's given a cap to indicate that it's been estimated. So for example, when you go to your regression, okay, and you now look at your price, the price here was what? 15. That's what you said. Most of you said that it was 15 for the third shop. The price is 15. The actual quantity was 160. But that quantity is Q, not a Q cap. Okay. The actual quantity is 160. But what is the Q cap? The estimated quantity. The estimated quantity, to get that, you need to use the model that you've just calculated. So let's go to the model. When you go to the model that we've estimated, it's 390.36, blah, 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 blah. So when you replace the 15, which was a price, and you replace that here at price here, and you multiply that 15 by the 14.26, and you subtract the answer from the 390.38, the answer you are going to get is what is known as the Q cap. And that answer, it might be equal to, of course, if the answer is equal to the Q that you had, the 160, then it means that that blue dot is on the line. So each of the Q cap that you calculate will be on the line. That is what makes up the line, actually. each of the Q cap, the Q cap is a predicted Q, is the fitted Q. Each predicted quantity demanded is the line. And as you have more predicted quantities, they will all be the line. So the line is reflecting the predicted quantity demanded. How do you get it for each one of them? Well, I just did a calculation here, but I don't want you to bore yourself because I'm going to use the package to install. So when you go to your next command, there's a command called fitted gen simple. Fitted gen simple. I just highlighted my run it. And when you do that fitted gen simple, it will give you the value of each predicted quantity. It will give you the value of each predicted quantity. Now, I want you to tell me the value you had for the predicted quantity for the third shop. You can tell me the third shop. What is the value of that predicted quantity? It is somewhere here. Instead of the 160, what is it there? You can see. Instead of the
176.
Good. So the value is 176. So what it means is that this particular shop was supposed, the quantity demanded for that shop was supposed to be 176. That's how much quantity should be demanded. Unfortunately, the actual quantity being demanded is 160. So there is an error. So what it means is that this particular value, okay, let me just make some stars here. This particular value is probably somewhere, you know, of course, the predicted is positive, okay, because the actual is below it. Okay. So if it is positive, it will be on top of the line. So it's possible that it's somewhere on top of the line here. And now that is on top of the line, the gap between the two, that gap is what is known as the error term or the residual. So the distance between that number and the line, the number on the line is the 176. And then the one which is not on the line, the actual is the 160. So the 176 and the 160, the gap is how many? How much is the gap? How much is the error? Who can tell me? Approximately. How much is the error? Between the 160, yes, relative.
16.
Good. So now let's run and see the error. So your next command is called residuals. The residuals are the errors. So we can calculate the gaps for each observation. Okay. When you run the residuals, look there, it is telling you each error. And the 16 that you just mentioned, that is the one that you have here. You have that error right here. Okay, you can see that right there. Negative 16. Okay, so the actual minus the predicted. The actual minus the predicted, that's error. So please put it down somewhere. The error is equal to the actual minus the predicted. And that is a negative 16.43. So on the basis of this, we can calculate for each observation its error, that is its actual minus the predicted. The difference between the actual quantity minus the predicted quantity. The difference between the actual quantity minus the predicted quantity. In other words, the error is equal to the Q minus the Q cap. That's what it means. The Q, and this error is what you want to minimize. You want to minimize using a method known as ordinary least squares. Write it down. Okay? You're watching me. You know, write it down. So that is.
So please repeat that again.
I repeat what? Because I said you should write it down. I should repeat. You have to follow.
Yes, sir, please.
The best way you follow me is you listen attentively and you ask questions. That is the best way. You give your heart to me whilst I give my heart to you in academic language terms. But if you are not asking questions, it means that you've not given me your heart. Okay? You are not here. You are here, but not here. So the difference between the actual quantity demanded minus the predicted quantity demanded is the error. And this error has to be minimized for each observation, has to be minimized for each observation using a method known as the ordinary least squares. It's in your slides. You're using the method known as the ordinary least squares. So the ordinary least squares method, what it does is that it minimizes the error sum of squares. Some of them are positive, some of them are negative. And after the minimization process, you would have now achieved the estimated regression. And the estimated regression is what we have down here, the red line. That is the estimated regression equation. This is for simple regression. In this estimated regression, we're going to explain a lot of things. But in the explanation of the lot of things, I will not use the simple, I'll use the multiple. But once you minimize the error, at the end of the day, we indicated that the mean of the error term must be equal to what value? The mean of the error must be equal to what value? We said it. If you were here and you have been paying attention lovingly, you know the answer. What's the mean of the error term? Angela.
It must be 0.
Good. So the mean of the error term has to be 0. Now, how do you prove that? Go to the command, which is known as mean of residuals. Mean into bracket residuals, gen simple. The model I'm using is called gen simple. So I'm going to find the mean of all these residuals. So it's like taking all of these residuals and adding them together. Let's run that command. When you do that, you'll get this value at the bottom. This value at the bottom is approximately what number? Who can tell me? This value at the bottom is approximately what number? It's approximately equal to what number? In management science, we explain some of these things a lot. Latif?
0.
0. So this means that there are 16 zeros before the 44089. There are 16 zeros before the 44. Of course, with a negative in front, but it doesn't matter whether it's negative or positive. So there are 16 zeros before the 44. So that means 0.0004, and that is approximately 0. And so truly, we have been able to confirm that the error term is truly, the mean of the error term is 0. You can find the confidence interval for each of the independent variable, in this case, price. And you can even find the ANOVA as well. I'll do all of that when we get to the multiple regression. For now, let's just generate some 3D graph. The one that you have here is a 2D graph. That's what you see, quantity demanded and then price. That is 2 variable graph, 2D graph, 2 variable graph. But what if we add another one, another variable, another independent variable? Let's say complement price. To do the 3D graph, you need to run a package known as RGL and tab. You already have it. You type the command you've already installed, so run that. And then use this command, which is scatter 3D, which regresses the quantity demanded on price and then complement price. Run that command. I'm just doing mine. The results will pop out somewhere else. Okay. It's a new pop-up. I'm clicking on that new pop-up. This is how your results will be. That, ladies and gentlemen, is your result. This result is not a 2D result, it's rather a 3D result. You can click on this chart and move it. Okay, you can move it and it will be swinging, but it is actually showing. No, let me show you when it was a 2D. Okay. When it was a quantity demanded and price, this is how it looks like. It looks like this. You see, downward sloping, quantity demanded and price. But now you can make it a 3D because we have added a C to it, and it becomes a surface. It's no longer a line, but it's a surface. Now, if you look at it carefully, when we make it even a line, you can see this. You look at it carefully, you can see that some of the lines have a vertical green line between the dot and the surface or the fitted. And then below the surface and the fitted, the gap is also red. Who can tell me why some are green for those that are at the top and some are red lines for those that are below? That is if you can see. And you should try it on your own. Who can tell me why? What do they mean? Why are some green at the top and some red at the bottom, at the below the line or below the surface? Anybody has an idea? There was a hand that came and went off. So those at the top of the line or the surface, they have positive errors. That is why they are showing green. And those below have negative errors. That is why they are showing that red situation. So this is what we mean by a 3D scatter plot of the regression. Then we can have a 4D scatter plot, then a 5D. Then now we are going into the world of polyhedrals, okay, and polygons and multiple polygons and polyhedrals. And therefore, using a graph to show them will be quite complex. That is why we use multiple regression approach to show all of them. All right, let me move away from here and go to our chart. So now we are going to do the multiple regression. By the way, there's another graph you can do. Okay. After installing the scatterplot 3D, you can also do with another graph, the same thing, but this is slightly different. That one, you see the C for the vertical, you see the Q for the horizontal, and you see the P also on the diagonal. And you have the data points are inside. They are inside the cuboid. This is again a 3D. Let's go to the multiple regression. Then we can now dig deeper and ask our 13 questions or 9 questions. The multiple regression. Run the command known as gene multi. Gene multi. Run that command. You see it in your command note. And when you run the gene multi, the result you are going to get is what you have down here. Look at the results down there. This result is similar to the result you will get in an exam situation, of which there will be several questions for you to answer, about 13 questions for you to answer. And so we're going to tackle each one of these questions one by one for you to be able to do the same analysis when you get your situation. But it's not for purposes of exam, it's for you to understand your own data. Suppose you're writing your long essay, your project, your dissertation, your thesis, and you generate a result based on your hypothesis, your research questions. You've gathered data, you've done univariate analysis, you've done graphical analysis, exploratory data analysis, and you are now doing some multivariate data analysis, which is a regression. And you've generated results like this. You're going to interpret some of the results just like we are going to do right here. So when you go to your slides, let's go to the first question. The first question I want to ask you, and I want to put that down, is this question. Question is, are you ready? Okay. Which regression coefficients or estimates are statistically significant? Which regression coefficients or estimates are statistically significant? How do you determine whether a regression coefficient is statistically? First of all, what is a regression coefficient? Ladies and gentlemen, please pay attention here. And if you don't get it, you ask questions. When you get the regression result, it is split into several columns. The names of the variables are in the first column. Okay. So when you get to your first column here, those columns here, that's representing the names of the variables. That's the first column here. The names of the independent variable. But there's one particular variable that is not an independent variable. Who can tell me that variable? No. Let me ask you a question rather. How many independent variables do we have here? How many independent variables do we have? Who can tell me? How many independent variables do we have here? There are two things, okay? There are two things that could be happening. Cynthia, are you there? Everybody,
So 8.
okay. So there are independent variables that are 8. Which one is not an independent variable? Which one of the information that you have here is not an independent variable? Sorry?
So the intercept.
Okay. Why is the intercept not an independent variable? You can tell me. Why is the intercept not an independent variable? It's not an independent variable. Why? Because it is not one of the factors that influence the dependent variable. Because it is not one of the factors which was from the data set. Every factor you see here is from the data set. Therefore, what is the significance of this intercept? It is also called constant, by the way. The intercept is also known as constant. In fact, when you go to Excel and you have to run Excel, the intercept sometimes can be suppressed. In other words, you can tell Excel not to show you the intercept because it is not an independent variable. It doesn't have any economic interpretation, doesn't have any economic meaning. It is only useful for cosmetic purposes and, more importantly, for prediction. The intercept is only needed during prediction. All right, so there are 3 independent variables. There are 8 independent variables. Okay, the first 3 are numerical, and then the last 5 are categorical. All right, now, each independent variable has got an estimate, and the estimate, come on. My screen is frozen. Each independent variable, okay, has an estimate. The estimate is also called coefficient. Take note. And please note this, that the estimate divided by the standard error will always give you the t value. This is important. I don't need to tell you to write before you write. The estimate divided by the standard error will give you the p-value, and you can try any one of them and it will get you the value of the p-value. The value of the t-value. The t-value is also the test statistic. Remember the t-test that we used to deal with? Okay, that t-test, that is the t-value here. So when you divide the coefficient or the estimate divided by the standard error, that will give you the t-value or the t-test statistic. And if you can remember hypothesis testing, we normally would take this t-value or this t-test statistic, and then we'll go and dump it boom into the swimming pool of the table, the t-table, and search for a number or numbers closest to that value, and then read a number at the top. That number we read is the p-value. The p-value is what you have at the end here. That is the probability of t, the t probability. So the PR is a probability, and that is representing the p-value. So please note, the p-value is the last information. Now, I'm more interested in this p-value. This p-value is what you use to determine whether an independent variable is significant. So use the p-value to determine whether an independent variable is significant. How do you do that? If the p-value is less than or equal to 5%, then that particular independent variable is significant. Note, if the p-value is less than or equal to 5%, then that very individual independent variable, that individual regressor, that individual predictor, that individual independent variable is statistically significant. Another way of saying is that it is statistically significantly different from zero. It is statistically significantly different from zero. So if the p-value is less than 5%, that's good news. If the p-value is equal to 5%, it's also good news. So you got to check each p-value for each independent variable to determine whether that independent variable is significant or is insignificant. Let's start with the first independent variable. Okay, so the first independent variable that we can see here is known as price. Okay, so I want you to look at the independent variable here. That is price. Price. And I'm looking at price here, and I'm looking at the value. And before you tell whether a particular independent variable is significant or not, convert the p-value to 2 decimal places. Convert the p-value to 2 decimal places. So who can tell me whether price is significant or is not significant? Who can tell me? Looking at the p-value, is price significant? And when we say significant, what it means is that it is able to not just influence the quantity demanded in this case, but is able to influence the quantity demanded in a powerful, in a very significant way. It's able to influence it in a wonderful, significant way. And that is what we mean by it is significant. So is price significant or is not significant? Of course, tell me why you say that. Give me a justification, a numerical justification why you said that. Wilfred Adebo.
It's not significant.
Why?
Because I think the p-value here, it's...
Tell me the p-value you are talking about before you tell me what it is doing.
The p-value of the price is 5.3%, which is higher than the 5%.
All right. That is not correct because you didn't do some things I asked you to do. So let's go to who is with me, who is dancing with me. Cynthia.
Yeah, so I think you said before we check whether the figure is significant or not, we should convert it to 2 decimal places. So if we do so, yes, do so, then it will become 0.05, and that is 5%. So I think it's significant.
That's it. That's it. So price is significant because its p-value of 0.05 is equal to the alpha level of 5%. Remember that the 5% you are checking it against is the alpha. Okay? And that is an indication that it is significant. Okay? At 5%, that is if you use 2 decimal. Now going back to the other gentleman, if we are not using 2 decimal places and we are leaving it open, then the percent is not going to be 5%, it's going to be 5.3%. Then in that case, it is not significant is not significant at the 5% level. Okay, because it's greater than the 5%. But even though it's not significant at the 5% level, it is significant at 10%. Why? Before we proceed, take note of this. It's significant at 10%. I said that. Watch. There is a star for each value. Normally, I talk about these stars after we have looked at using the p-value. So let me drop it and let me come back to this star. Okay, I'll talk about that later. So who can tell me the next variable? Complement price. Wilfred, your hand is up. Okay, the next variable is complement price.
I wanted you to take that again, especially where we had to convert the p-value to two decimal places. Is it in all cases that we need to do that after we had gotten this results?
For your purpose of this course, I would want you to use two decimal places before you determine whether it's significant or not.
All right, thank you.
Yes, all the time. Okay. But for your thesis, for your long essay, for your dissertation, you have to use whatever you see there. Okay, that makes sense of it. And again, when it comes to those theses, I'll get there. Okay. I normally organize seminars for students in the second year when they are writing their thesis. So, all right. Now, let's go to complement price. Complement price of gin is represented by C. So who can interpret the complement price? Sorry, who can tell me whether the complement price of gin is significant or not, and why he gave that answer? Why you gave that answer? Let me see. Wilfred.
All right, so converting this to two decimal places would have 0.01, which represents 1%. And that p-value is less than the level of significance of 5%. And so it is not statistically significant.
The last word, check again. And so
it is not.
It's not
significant.
It's
significant.
Not. Are you changing your answer because I repeated it's not, or you understand
statistically significant?
Okay, because you said it's not significant twice. Do you now understand why it's significant?
I think you indicate if the p-value is less than 5%, then the independent variable is statistically significant. Sorry, it is significant.
Exactly. But you did say that it's not significant. You've changed your mind now.
No, it's significant because the p-value is less than 5%. Yeah.
All right. So your words are what I picked you on. I wanted to be sure that you're not changing your answer because I said you are wrong, okay? But because you understand what you're doing. So this complement price of gin is significant because the p-value of 1%, and I've converted all already, the p-value of 1% is less than the alpha level of 5%. Therefore, complement price of gin is significant. Who can tell me about income? Who can tell me about income? Latif, and give reasons.
No, income is not significant because the p-value is 20%, which is above the 5% threshold.
Perfect. Location urban. Who can tell me about location urban? Eric.
Location urban is not significant because it is greater than the benchmark, which is 5%. 18, you get 18%.
No, it's not 18%.
No, it's not 18%.
He's going to change his answer.
19%.
So I want you to think through before you tell me your answers. You get a point. So just change your answer. Look through carefully and convert before you now actually analyze the answer. That is the way you learn. We are not rushing. We are trying to get it right. Okay. The next one, occupation teaching. Who can tell me, is it significant or is not significant? What the once the others get the max is finished. Sheila.
It's significant because it's less than the p-value is less than 5%.
Okay, ladies and gentlemen, I'm interested when a person tells me what the p-value is, what the actual value of the p-value is, instead of telling me it is more than or it's less than. Okay, so let me go to another person, Celestine. Celestine, repeat that wrong answer.
Yes, sir.
Mm-hmm.
No. So the occupation teaching is significant since the p-value is 0.
I didn't say occupation. I said go to location urban.
Location urban.
Yes.
It's not significant. The location urban is not significant since the p-value is 19%. That's greater than 5%.
Very good. You are now correct in both cases. Occupation trading. You can tell me about that. Occupation trading. Please, those of you who have raised your hand already, if you are not sure, lower it so that I know you are not right. Okay, Dauda.
You said we run it to 2 decimal places, which is 0.00, which is less than 5%. So it's significant.
Okay, religion, Christian. Religion, Christian. You can tell me about that. Latif.
Look, religion Christian is significant because there are 5 zeros before the 0.116. So when you run it, it equals to 0, which is less than 5%.
Good. Religion, Muslim. Religion, Muslim. Some are getting into the mood now. They are getting it. Sarah, Banner.
It's 0.00. So we'll say that it is not significant for religion Muslims.
That's wrong. Religion, Muslim. Sandra. Sandra.
It's significant because the p-value is 0%. When you run it to 2 decimal places, it will give you 0%. So it's significant.
Okay, all right. So you should learn how to determine the significance of all of these individual values. These are individual partial significance. Okay, not all of them put together, but individually put together. Okay, now at this stage, let me tell you something very important. When you check, and again, you won't get the stars. I will deliberately remove these stars. But normally the stars could have made things easier for you. In your thesis itself, you have the stars, so you can use the stars to determine. When a particular star, and listen please carefully because this is important. When a particular star is 3 stars, it means that that variable is significant at 0.1%. When the stars are 2 stars, it means that variable is significant at 1%. When it is significant at 1%, that's better because it means that it's also significant at 5%. When the star is only 1, it means that that variable is significant at 5%. So it means that the researcher made an error which was 5% or less. That's what it means. made an error which was 5% or less. So the person must have 95% confidence in the result. And when there is no star, but you have a dot, it means that that variable is significant at 10%. So normally when you're writing a thesis or a paper, you don't just say that the variable, say price of complement of gin is not, and in this case, because it has a dot, you say that it is significant at 10%. Okay, it is significant at 10%. It's not significant at 5%. When you take the 5.3%, that is more than 5%. So it's not significant at 5%. That is why you didn't get 1 star, but you got a dot, which means that it's significant, but it's only significant at 10%. When you are significant at 10%, you can never be significant below 5% or 1% or 0.1%. But once you are significant at 0.1%, you will be significant at all the percentage. So the more stars a particular independent variable has, the more significant that independent variable is in influencing the dependent variable. I'm done. I hope you get it. If you don't get it, you can ask a question. Let's go to the next question. The next question is, the problem with some students learning is that they don't ask questions. Sometimes they lose track, and when they lose track, they lose focus to ask. The next question is, are the estimates, remember the estimates is the same as coefficients, the independent variables coefficient. Are the coefficients jointly significant? It's not that first question. The first one was, is the variable individually significant? So the first one was looking at how individually each one of them is significant or insignificant, or insignificant. That's what it's doing. But the second one, it is trying to find out, put price of gin, complement of gin, income of the people, location of the shop, occupation or religion of the people. Put all of those together and tell me whether they have a significant effect on the dependent variable, which is quantity. In order to do that, to test for joint significance, you have to use the F statistics p-value. You have to use the p-value of the F statistic, and it is the last thing in your data, in your result. It's the very last thing in your result. So check the p-value. That's what you want to write down. Check the p-value of the F statistic to determine the joint significance. Use the p-value of the F statistic to determine the joint significance. How do you use it? If the p-value is less than or equal to 5%. Okay, so if the p-value of the F test, of the F statistic, the test statistic.
Samuel, what is number? Sam.
If the p-value of the F test statistic is less than or equal to 5%, then we can say that the independent variables, as all of them put together, are jointly significant. Then the independent variables are jointly significant. So ladies and gentlemen, I want to ask you, looking at our results, are are the independent variables jointly significant in our case, and why do you say so? You can tell us. The independent variables, are they jointly significant in our case? Why do you say that? Latif?
No, the IVs are jointly significant because the p-value is 16 zeros before the two, which is less than 5%.
Exactly, that's it, which is less than 5%. So that is a p-value of 0, which is less than 5. So it means that there was no error at all in making that predictive approach. So yes, all of them put together are jointly significant. Finish. Let's go to the next question. Okay. The next question is this. We are going to determine something known as the R square. The R square. And please note the difference between the R square and the F statistic. So when you go to your results, there at the bottom, you will see something known as multiple R square. The value is 99%. What is R square? There are 4 things I'm about to tell you about the R square. Please take note. The R square helps you to determine the reliability or the suitability of the entire regression model. It helps you to determine the reliability, the suitability, the fitness. I like that one. The fitness of the regression model. The fitness of the regression model. Now, what do we mean by the fitness? When you draw your regression model, you have some plots, and then you have a line, and you are hoping that all the plots, the scatter plot, will be seated nicely on the line. That's what you are hoping. If all the scatter plots are seated firmly on the fitted line, then we say that the regression model is well fit. Is well fit, is reliable, is suitable. The R square is also called the coefficient of determination. The coefficient of determination, and that is what you use to determine the fitness of the regression model. That is what you use to determine the reliability of the regression model. Like, we have a hypothetical fitted line, and we are hoping that all the scatter plots are nicely seated on the fitted line. But if there is a deviation from some of them from the line, how reliable are the variables? And this R square reliability measure, it is measured in percentage terms. And so you can, the higher the percentage value, okay, the more fit the regression model, the greater the fitness, the greater the reliability, the greater the suitability. So what then is the meaning of the R square? Write this down. The R square measures the fraction or the proportion or the percentage. The R square, it measures the fraction or the proportion of the total variation in the dependent variable. The percentage of the total variation in the dependent variable that is explained by all the independent variables. It measures the total variability, the total, the proportion of the total variability in the dependent variable that is explained by the entire regression line. That is explained by all the independent variables. So when you explain all the independent variables, we put all the independent variables together, they can have a statistically significant effect on the dependent variable. That is what the F test looks at. That is not what the R square looks at. Because the R square is not a test statistic for determining the significance of anything. It is rather a percentage value showing how much influence in percentage terms, how much impact these independent variables are having on the dependent variable. That is the R square for you. And if you want to know whether the regression model is fit, you want to have an R square value that is 50% or more. Take note. So if the R square value is 50% or more, then the regression model is well fit. Then the regression model is reliable. Then the regression model is suitable. The person who brought this guideline is known as Hare et al. 2005. I like it when unique special students are able to mention these things and also include the authors, Hare et al. 2005. It shows me that the student is distinguishing himself or herself from the others. So when the R square value is bigger than 50% or is equal to 50%, then we can say that a regression model is fit. This is not rocket science in the real application. In real application, some people have gotten an R square which is 3% and they still say that it's cool, it's good. Some have got 2% and they are still defending it and all of that. However, this is a general rule by Hare et al. That I've given you. So when you are making your situation, when you are making your analysis, when you are making your argument, use this argument as well in making your argument. Okay, so let's look at our R square. Given the value of our R square, what would you say? Would you say that our regression model is well fit or is not well fit? You can tell us. Is our regression model well fit or not? Eric.
Our regression model is well fit because it's more than 50%.
Okay, so more than. Relax, relax, relax. Don't use 8.
Because our R square is more than 50%.
Eric, next time relax. You made this situation twice. Okay? And use the right terminology. That's good. The R square is more than 50%, but you have to always mention the value. You saying that it's more than 50% is not enough. The R squared value of 99% is more than 50%. That is why the regression model is well fit. Okay, now let's go to the next thing, which is known as interpretation. Interpretation. Oh, by the way, if you have a question, you can ask. By the way, let me just quickly talk about the adjusted R square. The adjusted R square. Adjusted R square adjusts or alters the R square when irrelevant variables have been included in the regression model. It alters the actual R square when irrelevant variables have been included in the model. So imagine we are talking about a quantity demanded of gym bitters. We have included price. We have included complement price. We have included income of the people, location of the shop, and all of that. And then imagine somebody goes to include a variable like accident, or somebody even includes a variable like broken heart. Broken heart can cause an increase in the quantity demanded of gym bitters. And that variable is not a relevant variable. the R square value will still remain at 99%. But adjusted R square value will come down. Why is it coming down? Because that variable is irrelevant, and so it is punishing you by reducing the R square. So the adjusted R square is always, equal to or less than the R square. Who can tell me, when would the adjusted R square be equal to the R square? When would the adjusted R square be equal to the R square? When the values are all equal. All the 4 decimal places values are all the same for both R square and adjusted R square. What does that mean, Latif?
When there are no irrelevant variables included in the model.
Perfect, that's it. So when irrelevant variables are not included, then it means that we have a perfect situation of not including irrelevant variables for that particular model. It doesn't mean that it means that the model is fixed, because you can have a situation where the R square is 0.4 or 0.2, and the adjusted R square is also 0.2. And even though they are all equal, it means that you are not included irrelevant variable in this model. But this model itself has a problem, because the fact that the R square is 0.2 means that it has a problem. So you not including irrelevant variables does not make itself fit. There are a lot of unexplained factors that you got to consider. Okay. So the last thing I want to look at today, before next time we meet, is about interpretation of the independent variable, interpreting the regressors. Note that, interpreting the regressors. This is important because even in an exam, it's always, it's always 7 marks each. And in your assignment, it is 24 marks. So it's very important that you are able to understand interpretation. What do we mean by this interpretation? Well, what we mean is that each independent variable has got an estimate. Note that. Each independent variable has an estimate. And this estimate is known as coefficient. The value of each coefficient must be well explained. Some of the values are negative. Some of the values are positive. Sometimes all are positive. Sometimes all are negative. Sometimes some are positive. Sometimes some are negative. What does each value mean? What does it mean in terms of its influence on the dependent variable? What does this value mean? Some of the values are numerical values. I'm sorry, some of the independent variables are numerical. Some are also not numerical. They are rather categorical. For example, in our case, the last 3 variables are categorical. That's why they have English words, actually, letters. And the first 3 independent variables are numerical. And you can see this, by the way, in the Excel that you have. The way you interpret a numerical variable is not the same as the way you interpret a categorical variable. They are different. Wow. A numerical variable is a dynamic variable, so it's changing from year to year. It's changing. Price, for example, price is changing from year to year. Income, for example, income is changing from every year to every year. So that is not that is dynamic. It's not static. It's not statute. It's not dummy. But a dummy variable, like location, urban, like occupation, like religion, they are usually static within a year at least. You don't just get up every year, you're changing your religion. Even if some people do that, generally, that's not the case. And so such variables are dummy variables, categorical variables, qualitative variables. And the way you interpret them is different from the way you interpret a numerical variable. So what I'm going to do is I'm going to interpret one numerical variable to you. I'll give you time to write it down. Then I will also interpret one categorical or dummy variable to you. Then I'll ask you to do that on the rest. Right here for 3 marks each. So let me interpret one of the numerical variable, and I'm going to do price. And I'm waiting for you to write it down so that you will understand, will explain the interpretation, because this is important. The choice of words is important. Even though you might say in journal articles or in papers or theses or dissertations or long essays, sometimes people can use words like holding all other factors constant, holding all other factors constant, holding all other factors constant. For me, using those ones are cool, but they don't really mention the factors. So for this purpose of this course, I want you to understand the factors and understand the grammar that go with the factors when you are interpreting variables. So let me interpret price. Let's start with the word. On average, comma, given the complement price of Jane, right? Given the complement price of Jane. On average, given the complement price of Jane, right, faster. Given the complement price of Jane, income of the people, location of the shop, occupation and religion of the people, occupation and religion of the people, a 1 unit increase in the price of gin, a 1 unit increase in the price of gin decreases the quantity demanded of gin, by 3.15 units. By 3.15 units. Okay. I hope you got it. On average, it's a very powerful word that must come first. Why? Because regression analysis is average analysis. You're looking at the line of best fit. Then you remember I said given, and I mentioned those factors that have been given. I did not include the factor which is known as the price itself. Check. I didn't include price because I was explaining price. So I could not have held price as given or constant because I'm going to change it. Also, I understood the structure of the industry. I said income of the people, not of the shop. But I rather said location of the shop, not location of the people. Because you understand the terrain of the story. Then I also added that a 1 unit increase in the price of gin. Okay. A 1 unit increase in the price of gin. What does that mean? A 1 unit increase. So the 1 unit increase that I'm talking about is for the gin and for the gin alone. Gin price. So it's gin price, it's not any other price. So the value that you see, which was a negative 3.15. It's not for gin, it is for the quantity demanded. So I rather said a 1 unit increase in the price of gin reduces or decreases the quantity demanded of gin. Why decreases? You can tell me. Why decreases the quantity demanded of gin? Instead of just saying that, yes, can I do?
Because of the negative sign.
That's it. It decreases the quantity demanded of gin by the coefficient. You mentioned the coefficient. Note that I use the word unit and units. I did not use a 1% increase in the price of gin, a $1 increase in the price of gin, a 1 CD increase in the price of gin, a £1 increase in the. I did not bring in the specific unit of measurement. That's okay. I brought units. And it's very important to maintain that approach. Now, when you are dealing with logarithms, when you take the log in your real thesis, that's what I'm talking about. When you take the log of some of the variables, you have to now interpret your, especially when you take the log of the dependent variable. When I say log, I mean logarithm of the dependent variable. Then you have to interpret these units as percentage increases or percentage fall. So you will say that a 100% increase in the price of gin, blah, 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 blah. That is when you've taken the log. Other than that, keep it simple, unit. Very good. Who can interpret the coefficient of income for me? For 3. Who can interpret the coefficient of income for me? Okay. And just check through the one we've done for price. Then you will know how to go around the one for income. Who will try and interpret the coefficient of income? Wilfred Adobe first. Wilfred, I'm going to let you state it, and whatever you are wrong, I will not mention it until you are finished. After you are done, I will judge all that you said.
Okay, all right.
Okay.
Okay, so I'll try. So on average, given the complement price of gin, the price of gin, location of the shop, occupation and religion of the people, a unit increase in the income of the people will lead to a decrease in the quantity demanded of gin by 0.98 units.
Excellent. Very good. Very good. I love that. You did well. You did very well for that package. So guys, if you don't understand, see this champion man. He's very good in the way he did his interpretation of income. Now let me go to, so you got 3 from me. Let me go to how to interpret one of the dummy variables. The dummy variables. And what is a dummy variables here? The dummy variables, there are so many. I'm going to interpret that of religion Christians. Religion Christians. So take note. So I'm interpreting religion Christians. No, you let me interpret religion Muslims, please. Last one here. Religion Muslims. So we start with, on average, given the price and complement price of gin, given the price and complement price of gin, look, given the price and complement price of gin, comma, income of the people, location of the shop, income of the people, location of the shop, occupation and occupation of the people quantity demanded is expected to be quantity demanded is expected to be 23.01 units less. 23.01 units less. If the people are Muslims than Buddhists. If the people are Muslims than Buddhists. So what is Buddhist here? The Buddhist here is a reference category for the religion. How do I know that? I know that because that is the one the R did not bring. Ladies and gentlemen, the R will always never bring the reference category. So if there are 4 levels, it will give you 3 dummies. If there are 7 levels, it will give you 6 dummies. And the level it doesn't bring is a reference category. When I say the reference category, I'm talking about that particular level, which every other level will be mentioned relative to it. So you got to have that reference category. So whenever I talk about Muslim, I'm talking about Muslim relative to Buddhist. Anytime I talk about Christians, I'm talking about Christians relative to Buddhist. The reference category must be clearly known to you before you start the interpretations. That is how you interpret that. Now let's go back to this. I didn't say why you need to increase or why you need to know. After mentioning on average, and by the way, check, even though I was explaining religion Muslim, I didn't say giving Christians, giving religion Christians. Because Christians and Muslims, they are all religions. So you just have to, you cannot include the one you are interpreting as given. Okay. The same way you couldn't have said occupation teaching and occupation trading because they are all occupation. So saying given occupation is enough. And then here's the most important part. The fact that you should not make it look like the quantity demanded is increasing or falling. So you say the quantity demanded is expected to be, in other words, you are either a man or a woman. You are either a boy or a girl. You know, that is your sex type. Okay. Maybe you can look at other factors, but that is your sex type. You are either a Muslim or you're a Christian or you're a Buddhist. It's one of them. So it's not a matter of, at least within a year, is one of them. It's not a matter of you are increasing from a Christian and then the next year you increase to a Buddhist. Then the next year you increase to, no, that's not. These are static variables. And so it is expected to be blah, 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 blah unit less. Why did I use less? Less because when you check the 23.01, it is negative. So that's why I use less. If the people are Muslims than Buddhists, because I knew at the back of my mind, I was dealing with Buddhists, which is a reference category. Question is, will you remember at the back of your mind? Yes, I believe you will remember. So you will know that. How do you know that? The entire story will tell you. And even if the entire story doesn't tell you, when you run your R command, R will automatically use one of your levels as a reference category. Any question on this before somebody will interpret for me? Any question? So who can interpret the occupation teaching for us? Who can interpret the occupation teaching for us? These are all 7 marks. Okay, so Latif,
Oh,
yeah.
So for occupation teaching, I would say on average, quantity demanded is expected to be 19.43 units less if the people are if the people are fishing than no, if the people are.
So maybe what you should have done was to write it down, then you can get it.
Okay.
It allow you to.
So let me take it again.
No, put your thoughts together. Okay, then you come back, because that's the best way you want to go. Because you didn't put your thoughts together, you didn't write it down. I would suggest you want to write it down, then you come back. All right, Angela Davis.
So on average, given the price and complement of price of gin, income of the people, the location of the shop, the quantity demanded is expected to decrease by 19.42 if the people are fishing more than teaching.
Good, that's wrong. I'll later tell you what who can tell me the mistake she made? The ability to tell the mistake the person has made is a first step to answering it correct. Who can tell me the mistake is made? Use your full names, by the way. The people who raised their hand, they could not find the mistakes, Angela, you made. All right, Wilfred.
Okay, Doc, I want to try.
Mm-hmm.
I think the reference category will be a fishing, so it's comparing the teaching with the fishing.
Yes, but I didn't answer my question. My question is that what mistake did she make in her interpretation? Let's go to Elizabeth.
She mentioned it's less than 19.42.
It should have been what?
It should have been expected to be 19.42, not less than 19.42.
Okay. So she didn't use expected. Is that what you're saying? She didn't use expected to be.
Yes, please.
Okay. Yeah, if she didn't, that's wrong. All right. The next thing is she did not talk about the religion. When she was mentioning the factors that were given, she did not include religion. That's a big mistake that was done. So, you can give us a correct way of interpreting. Sorry, you didn't give a correct listing for teaching. Sorry, for religion, like I said. So, who can interpret the coefficient of occupation teaching for us? Another person to do the interpretation. Another person to do the interpretation to make a car. Agodia, can you use your real name so that I can give you? Other than that, I cannot give you any mark for this. Yes, Godia, go ahead.
So on average, given the price and complement price of gin, income of the people, location of the shop, the religion of the people, quantity demanded is expected to be 19.43 less if the people are traders than fishers.
That's wrong. I know you tried and did your best, but that's wrong. Who can tell me the mistake she made?
Wow.
You did not mention the word units. You did not say 19.43 units.
Okay.
Yes, you didn't. So that makes it not correct. Who can now finally correct those for us? See, your ability to sense that a person has corrected the whole thing is a first indication of you being right. Latif.
No, please, I want to ask the question before I attempt.
Okay.
So my question is, can I go ahead and say on average, quantity demanded is expected to be 19.43 units less if the people are teaching than fishing without doing the price of the complement, location of the people.
Okay, so I said that in this very course, I want you to learn. So you have to mention all the variables. In this course, I want you to learn. Because some of you don't even know what variable. You go and say P, you go and say C, you go and say M. When you don't really know what the variable, as you learn to know the variable names, it helps you to understand your thesis that you want to do. So yes, please learn to mention all. Okay, so that is how you do interpretation. Who is not clear in which one? Who is not clear in which one? Because interpretation is very key. Okay. Next time we are going to meet, we're going to look at a specification of the regression model, estimation, writing the equation, writing the actual regression equation down, and then we are going to look at prediction. Okay. And then I'll give you an idea about your assignment that you are supposed to submit just 23rd. Any question? Any question at all? Because this, if there is Miriam, are you there? Do you have a question for them, Miriam? Do you have an announcement for them?
Doc, please, I'm here.
Okay.